we have two circles, x minus 1 quantity squared plus y squared equals 1, and then x squared plus y squared equals r squared. They intersect at this point B here, and A is the y-intercept of the circle x squared plus y squared equals r squared. And so we extend this line going from A through B, and that intersects the x-axis at C. So we want to find the position of C in the limit as r approaches 0. So what that requires is to find out first what this line is. Okay, well, A is the point that intersects, that the first circle intersects the y-axis. So for that, you're going to let x equals 0. So you have 0 squared plus y squared equals r squared. That means y squared equals r squared, so technically y is the absolute value of r, which in this case, we know it's going to be positive because it's above the y-axis. Okay, so this will be positive r. Okay, so A then is 0 comma r. Now for B, you need to set both of these circles equal to each other. Well, in order to do that, what we're going to do is solve for y squared. Okay, so let's treat this as a system of two equations, two unknowns, and I'm just going to subtract both equations like this. So that's going to be x minus 1 quantity squared minus x squared. The y squareds are going to cancel, and that's going to equal 1 minus r squared. Now we're going to distribute or expand the x minus 1 squared. So that's going to be x squared minus 2x plus 1. Subtracted by x squared. That's equal to 1 minus r squared. X squareds are going to cancel, and you're just left with negative 2x plus 1 equals 1 minus r squared. Get rid of the 1's. Negative 2x is equal to negative r squared. Get rid of the negatives and solve for x to get that x is r squared over 2. Now, in order to find what that y value is, we can plug it back into either equation. So you can plug it into the x squared plus y squared equals r squared, or the x minus 1 squared plus y squared equals 1. It's going to be easier to plug it into the second equation. So why don't we just do that? So in place of x, we're going to have r squared over 2 plus y squared equals r squared, and that's r to the 4th over 4 plus y squared equals r squared. So then y squared is r squared minus r to the 4th over 4. And then finally, y is just going to be the square root of that. And obviously you want this to be positive because the intersection occurs above the y-axis. So we're just going to leave that as is. Okay, so the intersection for point B is r squared over 2, and then square root of r squared minus r to the 4th over 4. Okay. So we have the 2 points now, A and B. Because this is a y-intercept, we can use the slope-intercept form. So in other words, y equals mx plus b. So we know b is going to be r, because that's where it intersects. So now we just need to find the slope. So the slope will be the change in y over the change in x. So keep in mind here, a is 0 comma r. We're going to subtract the y values and then subtract the x values. So I can simplify this, and I can factor out r squared inside the square root. And then I'm going to bring out the r squared, so that's going to be r. And the square root of 1 minus r squared over 4. Factor out an r from both factors. And I can cancel out one of the r's. And then this 2, because we're dividing it, that's the same thing as multiplying the top by 2. So that 2 is going to distribute both the square root and the -1. And the nice thing is, this 2 can go inside the square root as 4. Okay, and then the 4 is going to distribute both the 1 and the -r² / 4 to get 4 minus r² inside. And so this is the slope. And then the y-intercept, we know that the point A was 0, r. So we're going to have y equals mx plus b. This is being m. And then b is just r. Okay. So just to be clear, what we just found was the equation of this line here. Okay. And c is, where does this line intersect the x-axis? So what we have to do is set y equal to 0 now to solve for x, because that's where the point C is. Okay, so let me just rewrite this nicely. We have square root of 4 minus r² minus 2 over r, that whole thing times x, plus r equals 0. I'm going to subtract r to both sides. And then let's multiply both sides by r. And just to be clear, this x is multiplying this whole thing, so we'll put it over here. So it'll be square root of 4 minus r² minus 2, that whole quantity times x equals -r². So x will be -r² all over the square root of 4 minus r² minus 2. And this is where point C is going to be. Okay. Now, the question asks, find the position of C in the limit as r approaches 0. So we have to take a limit now as r approaches 0 of this equation. The problem is, if I plug in r equals 0, I'm going to get 0 over 0, so that's going to be undefined, or indeterminate. So one way to do this is to multiply it by the conjugate of the top and the bottom. So let's do that. So that'll be the square root of 4 minus r², and then plus 2 this time, instead of minus 2. So we have limit r approaches 0, -r², and then square root of 4 minus r² plus 2. And then the bottom, you have a case where it's like a minus b times a plus b, and that one you get a² minus b². A being the square root, so if you square the square root goes away, and then you just square the 2 here. So you get limit as r approaches 0. The 4's are going to cancel. You have -r² times the square root of 4 minus r² plus 2 over -r². Now the -r² is going to cancel. And if I plug in r equals 0, I get the square root of 4 plus 2. That's 2 plus 2, and that's going to be 4. So that's going to be the position of C. Now I forgot to mention that this limit is as r approaches 0 from the right. Okay. And the reason is because when I took the square root here, I had r². This r² came out, so I did the square root of r², and I said that it was equal to r. That's going to equal r only if r is greater than or equal to 0. So let me just write this out. Otherwise, it's going to be -r. So here we assumed r was going to be greater than or equal to 0, and that makes sense because r stands for the radius of this circle. You don't talk about negative radius. Okay. So r obviously has to be positive, and r is a positive number, and you're going approaching 0. So you're approaching 0 from the right, since r is positive. So that's why the limit is 4. Otherwise, if you're approaching it from the left, it turns out that it's undefined. It's going to positive infinity. So therefore, the limit will not exist at r approaches 0. But in the context of this problem, it makes sense to approach 0 from the right, and that's how you get 4.